A load of 400 kilograms is lifted through 65 meters by a vertical cable. The load accelerates uniformly from rest for 10 seconds, travels at a constant speed for 25 seconds, and then decelerates for 5 seconds. Find the maximum speed obtained and the tension in the cable at each stage. So, first we need to calculate the maximum speed. Now, the best method to do this is to draw a speed-time graph. So, drawing a set of axes, we want time on the horizontal axis and v meters per second minus 1. Now, we are told that it accelerates uniformly for 10 seconds. Let's put some numbers on here. So, we've got 0, 10, 20, 30, 40. If we add 10 to 25, we get 10 to 25, we get 35 plus 5, that gives me 40 seconds. And then it accelerates up to 10 seconds. So we just need to put a line up here somewhere, like that so far. We don't know what this value of v is, that's what we're going to calculate. Then it travels a constant speed for 25 seconds, so from 10 to 35 seconds it will be a horizontal straight line, and then decelerates for 5 seconds back to its until it stops. Okay, so when it stopped there, it's at 40 seconds. So now, one important thing about a speed time graph is that the distance is represented by the area underneath the graph. So the area underneath here has to represent 65 meters. Right, so we can find the area of this shape because it's a trapezium. So we know that this distance is 25, i.e. 35 minus 10. So we've got 40, this distance, plus 25, times our velocity that we need to find, divided by 2 must be equal to 65. So 40 plus 25 gives me 65v over 2 is equal to 65. And therefore 65v is 130, and therefore v is 2 meters per second. Right, now that's answered the maximum speed. So this point here is the maximum speed of 2. And we know that a is v, the final speed, minus the initial speed, divided by 2. So stage 1 is at 2. So stage 1, the acceleration is going to be 2 minus 0, because it starts from 0, divided by 10, and that's going to give me 0.2, 2 tenths, which is 0.2 meters per second squared. In the second stage, there is no acceleration. We've got a horizontal straight line, so the acceleration will be 0, so constant speed. And in the third stage, we've got a deceleration, so it's going to be the final speed, which is 0, minus 2 over 5, so minus 2/5 gives me minus 0.4 meters per second squared. Now, the reason for calculating the acceleration is we need to find the tension in the cable at each stage using Newton's second law. Right, so finding now the tension, there's 3 stages. So stage 1, you need to draw a diagram. So it's a 400 kilogram mass. We've got a weight of 400 G newtons acting downwards, and a tension T1 standing for stage 1, and we've got an acceleration of 0.2 meters per second squared. So and we'll take positive as upwards. So using Newton's second law, the tension minus the weight, mg, is going to be the mass times the acceleration, and therefore T1 minus 400 G is going to be equal to 400 times 0.2. So that's going to give me that T1 is 400 times 0.2 is 80, plus 400 G, and then G is 9.8 meters per second squared. So we're going to have a tension of 400 newtons. In stage 2, if we draw the diagram again, this time we've got no acceleration, so therefore it's a constant speed at this stage. So therefore T2 minus 400 G will be equal to mass times the acceleration. So the acceleration is 0, so it will be equal to 0. And therefore T2 will just be 400 G. 400 times 9.8 gives me 3,920 newtons. In stage 3, Again, we've got the diagram. We've got the weight acting downwards, tension free acting upwards. We've got a negative acceleration because it's decelerating, so A will be minus 0.4 meters per second squared. So T3 minus 400g will be equal to 400 times minus 0.4. So T3 will be 400 times minus 0.4 is minus 160 plus 400g. G is 9.8, so that gives you 3,760 newtons. Okay, we weren't asked, but notice that the tension is the greatest in stage 1 when the acceleration is positive. Okay, so there's been a video to show you how to calculate the maximum speed and then use that to find acceleration in order to find the tension at each stage of a weight's journey upwards. I hope you've understood, and I thank you very much for watching.